colleagues, ladies and gentlemen. I'm gonna tell you about the Mycenaean Spercheios Valley archaeological program and how GIS and GPS technology were related to it in the last 2 years. So, a new 5-year field project commenced in 2018 under the directorship and auspices of the local Ephorate of Adnicotis, with the collaboration of Dickinson College, the Geophysics Labs of the Aristotelian University of Thessaloniki, the Architectural Design and Research Lab of the Demokritos University of Thrace, the Archaeometry Lab of the University of the Peloponnese, and the support of the municipality of Lamia and the Mycenaean Foundation. The Mycenaean Spercheios Valley archaeological project combines extensive and intensive archaeological survey, area reconnaissance, geophysical survey, target excavation, and digital technology in order to locate, identify, and map all Mycenaean sites in the Spercheios Valley. Geospatial analysis of geocumulative approach involving archaeological, geomorphological, paleoenvironmental, hydrographic, and paleoclimatic variables is conducted to explore interactions between environment and site distribution. Furthermore, statistical frequency and spatial distribution models are applied to trace contact patterns and hierarchical dynamics among the sites, and to identify second-order centers and possibly a first-order administrative center in the region. The region of the Spercheios Valley is in central Greece, features certain environmental, geomorphological, agrarian, and geopolitical parameters that, if considered collectively, may be construed as diagnostic formative elements of Mycenaean palastates. The Spercheios Valley, stretching for some 18 kilometers east-west, is wedged in between Thessaly and Boeotia, thus dividing the regions of central and southern Greece and allowing only a narrow shoreline passageway between them. Due to its key geopolitical location at the crossroads between powerful Mycenaean palastates on either side, Iolkos, Orchomenos, Thebes, and Glass, and other adjacent areas with strong Mycenaean presence, Locris, Euboea, this region could exert control on land routes and regulate local and interregional trade. The Spercheios Valley, covering a flat area of 370 square kilometers, is nearly landlocked, surrounded on 3 sides and protected by mountain ranges that delineate clear regional boundaries, allowing, however, eastward access to the sea. The hydrologic system of the Spercheios River, meandering towards its delta-shaped outlet in the Maliakos Gulf, with its 6 tributaries, form a well-watered fertile valley with rich alluvial soil, described by Homer as large land, and its own microclimate, agroeconomically ideal for large-scale agricultures in terms of land size, irrigation, and soil quality. Finally, the Homeric poems, epic poetry, and Greek mythology traditionally connect the Spercheios River with Achilles and his kingdom in Phthia, thus preserving the collective memory of a possible palastate in the region. Paradoxically, however, the archaeological map of the Spercheios region is incompatible with its geopolitical importance and economic potential. In the last 2 centuries, archaeological fieldwork was carried out sporadically in the Spercheios Valley, with rather poor results, partially because field research often aimed not at the surrounding hills, but at the modern valley floor, therefore being hindered by local political geological processes, deep silting from the river, and sinking of the southern part of the valley floor by 10 to 20 meters due to the earthquake fault of the mountain Atalante. Recent work by the local archaeological Ephorate has located and partially excavated a few Mycenaean sites and cemeteries, such as the important cemetery at Kopotales that has yielded large chamber tombs with exquisite finds, imported luxury goods, and artifacts of high social status, thus indicating a region that may be moderately secluded but not isolated, combining local autonomy and self-sufficiency within the regional contexts. Our field research, according to the new 5-year field project, has identified a potential candidate for a regional administrative center in the ancient citadel of Lamia, on the basis of geopolitical and topographical parameters, promising geophysical data and old test pits that yielded Mycenaean wall remains and palatial ceramic evidence. Anyway, the strategic and economical potential of the region practically eliminates even the remote possibility of a geopolitical vacuum in the area. Nevertheless, if verified by excavation, the presence of a regional administrative center on the Lamia, once controlling the land trade routes, commanding access to the shore, and regulating the regional agricultural production, would drastically change the political geography in the periphery of the Mycenaean world. This project, therefore, will seize the rare opportunity to combine field archaeology with advanced archaeological science and traditional classics, and may face the challenge to juxtapose historical reality with myth. Moving now into the relation of GPS technology in field survey, we will see the analysis suggested in this paper. The analysis can be divided into different stages in order to be more understandable as the methodology used to extract the results from the study area. In the first stage of the methodology, the maps required in order to include the study area were collected and digitized, highlighting the geomorphological, environmental, and geological characteristics that will later assist in accessing each location separately, but also the area as a whole. For this purpose, a GIS base map was created that could accurately represent the overall landscape, while at the same time provide the necessary diversity of information required in the spatial analysis. Following the development of the initial information, the task was to represent the archaeological information spatially on the study area map in order to acquire the accurate position. In other words, where exactly the archaeological information is located in the study area. The field research was carried out for three main reasons. The first and most important was to obtain the exact coordinates of the locations. The second was to enrich the spatial and archaeological data with their associated photographs, and the third, and the very basic for the science of archaeology, was that of recognizing the characteristics of the landscape. Under this light, for the collection of archaeological data and its spatial integration into this area, were recorded into a TOPCon GPS positioning station, as well as the coordinates of the archaeological sites visited. The TOPCon station operates using the phase kinematic technique and can accurately determine a location with a deviation between a few millimeters to 1 centimeter. Finally, it should be noted that both the collection of coordinates and the processing of the data used the transverse Mercator projection TM87 of the Greek Geodetic Reference System 1997. The Greek Geodetic Reference System is the unified projection system used nowadays in Greece, both in the private and public sectors of the country, and is the required and unique reporting system acceptable to all services in Greece. Each location visited with a relevant to the overall archaeological studies needs was determined by the available bibliography. The study group physically visited in cooperation with the local Ephorate of antiquities and with the help of their collaborators the indicated locations which in the bibliography were only mentioned descriptively. Thus, the effectiveness of the GPS in the field was apart from the obvious recording of coordinates for exact position. Also, to measure equal parallel distances for scanning the study area by the field group, the archaeologist who had to survey a large area for findings. The methodology followed was to divide the area into grids consisting of equally sized segments, squares, perpendicular lines, and equal spaced points forming a rectangle, whose size always depended on the area to be surveyed. In that way, the field team had a better perception of the space they had to travel and remained committed to it, maximizing the result. The study area was divided and surveyed according to standard extensive surface surveying, walking survey methodology, divided into equal distances with two subgroups, the first one heading south to north in the relevant grid and the other west to east respectively. This ensures that the area is surveyed twice once by each group, initially by those that moved on the south-north axis and those on the west-east axis. Locations where objects, either small artifacts such as pottery fragments or large such as tombs or piled stones, were marked using different colored survey flags for the two groups that moved parallel west to east, as indicated by a red color, and vertically south-north with blue. This activity resulted in an exact number of occurrences per group, visualizing which team was the most effective in observing the site, and in cases where there there were two flags, we knew that both groups had noticed and considered the subject as an archaeological find. This method could be used by universities as a means of assessing the effectiveness of students in research. Finally, using the GPS, all flagged points were recorded, resulting in the spatial visualization of the density of the objects found with their coordinates over a large survey area defining archaeological interest zones. Additionally, the project included a geophysical survey, specifically an electrical resistivity tomography (ERT) or electrical resistivity imaging (ERI) survey, requested by the archaeological team that was realized by the team of the Applied Geophysics Laboratory of the Department of Geology of the Aristotle University of Thessaloniki and under the guidance of Professor Grigoris Tsoukas. ERT requires information of a grid of points where the electrodes were placed in order to facilitate the later correct spatial placement of the survey results. The GPS station was used to record the points of the grid in order to ensure the maximum topographic accuracy required for its placement, since the result of the underground recognition of the space would have to be placed in their correct position to identify the same space in future use. The geophysical survey was realized in 6 areas in the area of Lamia, the castle of Lamia, for which 6 different grids were created and recorded, indicating the exact location of the results. Therefore, the contribution of GPS to this methodology has been valuable, as in just a few hours we had recorded the exact points of the grids for each examined area within Lamia. The points were easily imported to the survey computer in order to identify the area under examination. In conclusion, the benefits of using GPS in the geoarchaeological research program at Lamia are determining precisely the location of the points of interest, creating virtually the framework on which the research will focus, documenting in a fast and relatively simple process using the HAPOS network, which only requires the presence of the rover station, while internet coverage is secured through 4G and other available cellular networks. Identifying by using the exact position with their elevation, other functions of points of interest, lookout towers, communication networks, beacons, recording the coordinates of the geophysical survey grids along the exact points to be redefined for future excavation of the site or the creation of an archaeological section. And last, contributing substantially to the surface field working group by clearly defining the survey area to be covered without deviating from course and identifying the coordinates of the findings, creating specific interest zones. Thank you.